Hello everyone and welcome back to the Intro to C course MCS 1142. Today is week 8B, which is July 8th, summer 2021. Today, according to the syllabus, we're gonna go over chapter 9, which is C, formatted input and output. So how to format input streams and output streams in C language. In this chapter, you will learn how to read and write data from and to the screen in a custom or a specific order or representation. With that being said, I'm gonna go over the two topics from the book one by one. The first topic is integer conversion specifiers and integer conversion specifiers. So before I start, you need to know that stuff for printf are different than the stuff for scanf. They share some common specifiers, but there are specifiers specific to printf and there are specifiers specific to scanf. So I'm going to start with the printf section and go over all the topics that you need to learn, and then we're going to go over the scanf topics and demonstrate them. So for printf first, for printf, you have the first topic is how to convert integer. So integer conversion specifiers. You're gonna have stuff like D, I, H, L, LL, O, U, X, or capital X. So I'm gonna go ahead and type the code and then show it to you. Okay, so I typed all the different specifiers. This is a classic example you have been working with, which is display a D, display a decimal, and this is the number. I is similar to D in printf. There is no difference. This decimal, this says integer, but in printf, they are the same. Here, I'm showing you in D, when you display a D, the plus sign will never print. However, the negative sign will always print. This is telling my printf that the following number is going to be a short D. This means if a scanf needs to read, it should read it as short D. Why? Because printf displayed it as short D. So someone outputs a stream as short D, then the input stream should read it as a short D as well. This is telling it that it's a long D, and this L makes it this literal long. This is an octal. Octal is base 8. So you learn to write, as of now, you learn base 2, which is 1 or 0. Base 10, which is 0 to 9. You learned hexadecimal, which is 0 to 15, where 0 to F. Octal is 0 to 8. So I'm telling my printf, hey, this 4455 is an octal value. So printf will take this number and convert it to an octal base, from base 10 to octal. This is telling it that it's an unsigned number. Unsigned number means it's always positive, from 0 to maximum. So unsigned for 455 is the same. However, unsigned for a negative, since it's unsigned, it will convert this negative to an unsigned. And there is a way to do it, which is if your range, if you have, since it's unsigned, that means it's 0 to max. Let's say max is 100, just for an example. Then if I want to display unsigned 15, what's going to get displayed on the screen is 85. Why? Because there's no negative in unsigned, so it's going to take minus 15 from the maximum. So it's going to reach the maximum and then go back 15. So negative 15 from the maximum, which is 85. In this case, the minus 4455, the minus 455 is going to be subtracted from the maximum integer. remember the max int, the maximum value of an unsigned integer is gonna be subtracted by 455. So if I wanna run, this is telling it hexadecimal. So hexadecimal small letters means if you see A, it's small a. If you see B, it's small b. This is telling it it's a capital letter hexadecimal. So if I run and I move it, so this is the classic one, this is the classic one. This shows that I'm missing one. Here it is. So this shows that the plus sign, the third one, the plus sign doesn't print. However, the negative sign will always print. This is telling it it's a short int, long int. So just the way it's specifying it on the print. So the scanf needs to read it as a long, the scanf needs to read this as short. This is octal. So 45 in octal in base 8 reaches 707. Now 45 as unsigned, it's positive. So here it is. Negative unsigned is the maximum integer value minus 45, 455. This is hexadecimal small letter. Notice the C is a small, hexadecimal capital letter. So this is the first topic in output specifiers. And these are the different specifiers. Then you have the float specifiers. So these are all for whole numbers. I'm going to comment them out. Then here I'm going to say double or float, which is like a number with decimal values. So it has a point something. So float conversion specifiers are something like E or E, F or F, G or G, L, etc. So I'm gonna go ahead and type the code and walk you through it. So these are the different specifiers for float. This says exponential, capital exponential, float, small letter G, capital letter G. This is the classic one. It's gonna display it as is. Actually, it's going to display it as an exponential representation. So it's going to be 1.1.2345678 E plus 6, because we moved the 0.6 point. So it's going to always display one significance and then dot whatever the numbers are converted, represented in an exponential value. This shows that the plus sign will not display. This shows that negative sign will always display. This shows the same as above, but the E is going to be capital letter. Again, all these might sound same in printf, but the way you print them has to be the way you read them. So if they are read in a capital E, they have to be, if they are written in a capital E, they have to be read by a capital E specifier, unless you're doing like some micromanagement into it, or a different language has it all figured out. So it always depends. But for this class, you're gonna learn this. This is the float representation. Float representation will always display last or first 6 numbers after the point. So it's gonna display 890000. G will basically depends on the magnitude on the number, will either display it in a float representation or in an exponential representation. So it will figure it out for you, depends on the magnitude of the number. So if I run, you're gonna see first one is the classic. So 1.2345678. I'm missing 778. So it actually rounded the number. So it rounded the number and then it moved the 0.7. So E plus 0.7. Same with this, but it will never display the positive sign. It will always display the negative sign. This is capital E. So notice the capital E instead of small letter E. This is the float, which is 6 numbers after the point. This is based on magnitude. So the magnitude of this number will be displayed as this representation. So let me stop this to go over printing strings. So when printing strings or characters, so I'm gonna give it printing strings and characters. In this case, you have a C or S, or that would be it. So it's gonna be, let's say I have a char my character equal A, for example. And then I have char my string equal this is a string without the new line for now. Then I'm gonna say it's an array. So then I'm gonna say I would like to print a character with a new line, and that character is whatever my char is. Then I'm gonna say printf. In this case, I'm gonna display a string with a new line, and that string is my string. I will also do it as a literal, so printf also string, but this time this is another string. And we can do it as instead of which is the same, but instead of this declaration declaring an array of string, I'm going to declare a pointer to a character array. So I'm going to say it's a const char pointer, and it's called my strptr, and I'm going to assign it literal right away. So this is also a string. And in C, as you learned, it will append a terminator, null terminator at the end. It will append a null terminator at the end. So when I print f and I say it's a string, then this printf will go and print all characters until it reaches a null. So my str pointer. Now if I run, I need to comment out those. Run. So I'm displaying a character A, I'm displaying a string, my string, this is a string, here it is. This is also a string, so I'm displaying a literally as is. That's why they called literal values, because everything between quotations is literal as is. Also a pointer to character, this is also a string. So how to display character and string, this is how we do it. So I want to comment. Next one would be is how to print pointer values. So print pointer values. Let me go ahead and collapse these. That's just so we are. So for example, in here you have P. It is actually just P, but extra you have the percentage. So basically I can say I have an variable 1, 2, 3, 4, 5 initialized. Then I have a pointer to that variable, ptr equal whatever the address of that variable. So whatever the address means, the reference of that variable. So a pointer is a variable that holds or carries a reference to another variable. A reference is a memory address. Then I can say printf. I would like to print the value of ptr is whatever as p new line, and then I give it ptr. Then I can say printf with the address also of x is also new line, and then I can give it the reference of X, which is the address of X. And for the percentage, we're gonna say printf, printing literal percentage sign. So now if I run it, so the value of PTR is, notice how it displayed it as a pointer representation. So the full representation. Also the same, the reference of X is whatever the pointer is carrying. And this is how print literal percentage, because if I don't, because if you put 1% sign, then it's gonna consider it, hey, I'm expecting a specifier. It's not gonna know that, hey, I want to actually display a percentage sign. Similar to escape sequences. Remember escape sequences? Like if you wanna display an actual double quotations. If I put the double quotations here, then I messed up my code. So I need to escape that rule and tell it, hey, I meant it. I meant to display a double quotation, similar with the new line, escape sequence. So this is how you display a pointer value, or most of this you need to actually like memorize them, like how to display a pointer value, how to display a hexadecimal, etc. Let me close this. The next would be how to print with a field width. So print with field width. So for example, I'm gonna do it like this. I'm gonna say 4D, which is 1. Then I'm gonna say 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. So 1, 2, 2, 3, 4, or 2, 3, 2, 3, 4, 2, 3, 4, 5. And I'm gonna keep these like this. Then I'm gonna do the same to show you what happens with the negative. So negative, 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 save, run. Print with field widths. Yep. So, oh, we forgot the new lines. So new L. And here I'm gonna say print 1, 2, 3, 4, 5, 6, 7, 8, 9 / n go. So notice, since I told it I want 4, means whatever the number I'm giving you, I want it to consume 4 characters on the screen. So these are the numbers of my characters. This is the first character, second character. Notice that 1 is at the 4th character. 2 is at the 4th character. 3, same. So this is called right justification. Right justification is by default. So I told it I want to consume 4 characters on the screen, but the number is displayed on the right of the 4 characters. This is right justification. I can do left justification by doing -4. Means I want the number to consume 4 characters on the screen, but the sequence starts from the left of the 4 characters. So if I do -4 and then another number, that number will be displayed on the 5th character. So it's going to be 1, 0, 1 space, 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 and then 2 space, space. Why? Because I told it I want this number to consume 4 characters on the screen. So those 4 characters are going to be allocated basically on the screen. Notice what happens when you are out of the bounds. When you are out of the bounds, you're gonna go out of the bounds. It's not gonna ignore any number. It's not gonna trim or cut any number. It's gonna display the number as is, and it will try to put it within 4 characters, justified right, as long as it's within 4 characters. If it's after 4 characters, then it has to display it as is. Negative sign, notice it consumes a character. So it started going out of the bound at 5 at this position, unlike here. Why? Because the negative sign will consume a character on the screen. So this is called field width. If I do negative in here, means left justified. Now notice it's gonna start from the left. So this consumed 4, this consumed 4, this consumed 4, and then this is out of the boundary. So for example, if I wanna display another number, which is 3, notice the 3 is at the 5th character. So this number consumed 4 characters. Now this number is at the 5th character, is consuming only itself because I didn't specify. I didn't specify how many is this gonna consume. If I tell it I want to consume 4, then it's gonna be right justified. So look what happens. This is left justified, consuming 4, and then this number is also consuming 4, but it's right justified. This is very important. Why? Because basically, if you want to display data to the user, you need to put tabs, you need to put them organized in columns. Right now, if we display them even without a new line, it's going to be messy. So just by adding a new line, everything is clearer. So imagine if you have a lot of data and then you want to display them at once. Maybe it's a game, maybe it's a airlines or whatever the program is, and you need to display some data, you will need to right justify or left justify just so the data looks clearer to the user. Like let's say a header column. So header 1, header 2, column 3, 4, 5, then you justify, you allocate, for example, 20 characters for each column, and then you left justify them. Also for the first row, you do the same, second row, you do the same, then they're gonna all straighten up under the column in a vertical fashion, in a clear fashion. So with printing with field, this is with the printing with field width. The next would be, let's do printing numbers with precision. So let's comment this out and undo this. Comment. And then I want to do with the precision, and I'm going to do it in a similar fashion. So print numbers with precision. What I'm going to do is I'm going to say printf f 1, 2, 3, or maybe 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, then 20, 30, 4, 5, 6, 7, 8, 9, etc. So these are just to number my characters on the screen. Maybe I don't need this first character, 10th character, etc. Then I'm gonna say print or declare a variable first. So int my var equal 1, 2, 3. Then I'm gonna control or specify the precision of this number. Yes, it doesn't have any decimal value after the point, but I'm gonna be able to display it in a specific fashion. Let me declare, as a matter of fact, declare another one called my double. So my int is this, my double is 123.94536. Then I'm gonna say I have also a character array, which is a string. I'm gonna say happy birthday. With that being said, let's start printing. So printf, I'm gonna print tab, just to show you the tab. Then I'm gonna say, hey, I would like .4 from that D, only .4. So .4 means I want you to consume 4 characters on the screen, and if there are any spaces or emptiness, fill it with zeros. So for example, if it's 1 2 3, then it is 0 1 2 3. So the emptiness is filled with zeros. Then I'm gonna say new line, my int. So I'm gonna do it the same, but this time I'm gonna say 9. That's for the int. For the double, I'm gonna say print f. I would like you to print a tab, and I would like you to print a number that is .3f /n. And right now I want you to display my double. In another fashion, I want you to do 3e, just to show you how it's gonna work instead of f. And third time, I would like 3g. Last, for the string, I'm gonna say printf. Also a tab, just so they are all aligned. I would like you to display 11s, or it's just called s. Now look what happens. So I told this number, I told it I want it to be filled by zeros up to 4. Oh, why is that? Oh, because of the tab. Oh, I see. Okay, because of the tab. Here it is. I forgot a new line on here. You see? It's right there. So I forgot a new line. So let's do that. So let me remove the controller from my face. There is this zoom controller in my face. Okay, it's gone now. So 1 2 3, I told it I wanted tab and then consume 4 and fill it with zeros. In this case, I told it to consume 8, consume 9, sorry, and fill the rest with zeros. So we have 6 zeros. Then here I told it I want 0 3 float, means remember float will display first 6 numbers after the point. Here I specified, I said I only want 3. Only show me 3 decimal points. In this case, I told it I want it as an exponential representation, but I only want 3. So here it is. So it only shows the 3 points after, 3 numbers after the point. In this case, it converted it based on the magnitude. Based on the magnitude of this number, 1 2 3 9 4, it converts it to 1 to 4. Why? Because 1 2 3 9 is very close to 1 is very close to 1 2 4. So it rounds up. And for the string, I said I want to display 11 characters. So notice 1 2 3 4 5 6 7 8 9 10 11. So only 11 were displayed. If I tell it I want 15, then it's going to display all 15. So now it's happy birthday. I don't see it. What is it? Oh, here it is. Happy birthday. 15 characters. So I specified I want only 11. So this is how you print numbers with precision, or other than numbers also. You can print strings with precision. Next, I want to show you is maybe more about right versus left justification with the strings, with double, just so you get better understanding with it. So I'm going to comment, and then I'm going to say, keep this like this. And then I'm going to send you this file for your records. So once you run this code, you only want to uncomment this section and then this section. So only the code. The rest are not to be commented out. So now I'm going to say right versus left justification. Justification. And then I'm going to say, give me this bad boy. Also put it here. Here it is. And then let's say printf. In this case, I'm going to say print 10s. Then print 10d. Then print 10 characters. Then print 10 float. Then print a new line. Yep. Here I'm going to say the string is hello. The D is 7. The character is A. And the float is 1.23. Then I'm going to do the same. And I'm going to add left justification, left justification, left justification, left justification, and then I'm going to run it. So notice 10s means I'm giving you a string. I want to consume 10 of that on the character. Notice the difference. This is 0.11 means only display 11 characters. Here I'm telling it I want to consume 10 characters on the screen, and this is right justified. So notice hello started at the 10th character. So it consumed 10 characters and it is right justified. So it is from the right to left, OLLEH. On the opposite hand, it also consumed 10 characters because notice the 7 started at 1. So this hello also consumed 10 characters, but it was left justified. Same case for the 7. So 7 consumed 10 characters and it was right justified at the 0. 7 consumed also 10 characters, but it was left justified. Similar to the A, both consumed 10 characters. One is right justified, one is left justified. And for the float, I said I want to consume 10 on the screen, and it is right justified. So notice this is the 10, so it started with 6 characters after the point, and it consumed 10 characters. It happened the same here, and it consumed 10 characters. If I display more, they're going to be displayed at this character, starting from here or here. So this is right versus left justification. Boom, boom. Another thing maybe you want to see is how to use space. So use space flag, we call it space flag. So printf, I'm gonna say print d, the space /n, another d with the space /n. In this case, I'm gonna say positive versus negative. Printf. So notice here, the positive sign is not going to be displayed, but what I told it is I told it to print a space character first and then the number. So space character first and then the number. In case of a negative, it's going to fill that space flag with the negative sign. So it's a good habit to always leave a space flag just in case you have positive, then negative, and it is all left justified. So you want them to be aligned with each other. So you always leave that space flag. It either fills it with negative or it's just a space. So that's a good habit to follow when you are displaying on or writing to a text file or displaying on the screen, etc. The last thing you need to know in printfs are what we just mentioned: escape sequences and printing literals, if you want to print literals. In this case is what we saw. Um, let's see. So I start with, let's do it constructive. So I can do single quotation, or let's do it like this. I can do it as single quotation, double quotation, question mark to display question mark on the screen. I can do backslash. I can do alert or sound. I can do backspace, means move, no, move back, let the cursor move back one character. Can do go to next page, means move to the next form or next feed in a stream. Similar to a new line, but next page, next form, next pipe, next stream, basically. New line. I have carriage return, so meaning start over from the beginning of the line. Move the cursor to the beginning of the line. I have tab. You just seen the tab, and I also have vertical tab. Yeah, this is basically you need to memorize this. Keep them in your mind. You have vertical tab. So if you see something inside and I ask you what is this, you need to know what is this, what's the output of that, or what's wrong with that, or what does this do, what's the output, basically what's the output. Or if I ask you to print it, you need to know how to write it. So for printf, I think that's it. This is for printf. Printf. What else? I think that's it for printf. Next is scanf. So scanf. First topic is scanf. How to read what we just did. So reading with conversion specifiers. So basically, whatever you wrote using the printf, then you need to read it using the printf. So for example, I'm going to say int a, b, c, d, e, f, g. Then I'm going to say scanf. I'm going to scan a d. Then I'm going to scan an I. Then I'm going to scan negative I. Then I'm going to scan hexadecimal as an I. Then I'm going to scan octal. Then I'm going to scan unsigned. Then I'm going to scan hexa. And I'm going to put them. First one is here. Second one is here. Third. Boom. Then I'm going to print them. I'm going to all print them as these to show you the difference. So 1, 2, 3, 4, 5, 6, 7. So 2 more. Boom. Yeah, that's it. I wanted to show you that the I can input, so this I can input the decimal, octal, and hexadecimal. So I'm going to go ahead. I'm going to say -10, and space minus 10, 0, 1, 10, 0x, 10 as hexa, 10, 10, 10. Now what's gonna happen is I read at I didn't print anything. A, B, C, D, E, F, G. Close it. Start over. Start over with a new line. So we said minus 10, minus 10. It was 10, then hexa 10, then 10, 10, 10 for positives. Go. So minus 10 as is. The I was able to read a decimal. It was also able to read an octal. So the octal 10 is 8. Um, hold on. So if I read I, then convert it to an octal. Yeah, don't worry about this. I'm gonna fix it later. This is the second I. So the third I, which is hexa, it told me that in hexa, this is 16, which is correct. In hexa, the 10 means this went through 15. So 0 to all the way to F. So this is the 16. This is the 16th character. 16th value in decimal. So 10 octal is the 8 in decimal. And then 10 was read as unsigned. So it's 10. And then the hexa 10 is 16. So this is correct. I think I think 1, 2, 3. This is not making sense, or I did it wrong. Anyway, so notice how I read a type. Now, if I display them in the right type, then they're gonna be displayed the same as I read them. Space, 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 space. Oh, it wants me to negative 10, negative 10, 0, 10, and 0 times 10, 10, 10, 10. That was our example, so, right? Go. Oh, display them the same. I-O-U-X. Displayed these the same. Oh, this needs to be read as an hexa. So fourth one would be an X. And then third one is octal. So O, O. Again, minus 10, minus 10, 0, 10, 0x, 10, 10, 10, 10. Yep, here you go. So next topic is to read the float with the scanf. So I'm gonna comment these. Then I'm gonna say reading float. Oh, we don't have time. So before I go to float, with reading, I want you to learn about scan sets. So scan sets, and because the rest are easy, really. They are just demonstrations. So scan sets you need to learn about. Skipping characters you need to know about. Field width, you already learned field width. Field width, so how to print with the field width and how to read with the field width, and they are the same basically. I recommend that you go and look at the book how they read with the specific width. So it tells it read consume 8 characters on the screen and get me the number out of those characters. So on the screen, there is a number 8 that consumes, for example, 5 characters. Then scanf will read 5 characters on the screen and read and take the number out of those characters. So with that being said, because we are about to finish, I want you to learn about scan sets. So scan sets means when reading, you are telling your scanf to read only specific characters. So you are giving it a set of characters, and then the scanf will ignore any other characters. For example, let's say I have a character, and then I have a um no, I have string. Let's say I have string my str of size 10, right? And this string is gonna be red. It's gonna be red. The scanf, I want 9 characters, right? Because 10 is 9 characters, keeping 1 character for the termination. So I want 9 characters out of A, E, I, O, U, vowel letters. Yep, and put it in my str. Then I'm gonna printf my str to show you what it's gonna display. So read 9 characters only from that set into my string. So if I go ahead, failed, printf, printf, printf. So I'm gonna say ASDFG QWERT ZXC da 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 da. Oh, interesting. Extra argon F or S. Wah, wah, wah. Yeah, this is correct. Go. Oh. Oh, I didn't tell it. I didn't tell it to read. La, 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 la. Capital letters, small letters. Boom. So now my string will have hmm? What's going on? I'm not gonna let you go before we figure this out. Scan, set, C language. There's nothing wrong with that. So read from this S into this. This is what I'm doing. Read into S. Yeah, and F, print F without the 9 for now, just to match their code. Same. What's wrong? Did they change it? This is to ignore. Ignore new lines. Ignore letter R. Read 9 S into my string. It's not writing. FS. I will look into this later. How about if I tell it to ignore? I will look into this later. What was our next topic? Or give it a try and let me know. Give it a try. Maybe I'm doing something wrong. Or look in the book, see how they did it, and let me know. Let's comment this out. Skipping characters was basically for dates. It's good for skipping characters when you ask for a date. For example, the user enters like some users enters the date like this. Some users enter the date like this. So you always want to grab a number, ignore a character, grab a number, ignore a character. So you want to skip some characters. And the way you do it is you say, let's say int month equals 0, int year or day equals 0, int year equal 0. So I want to read the date as numbers. Then I'm gonna say scan f. I'm gonna scan a d, and then I'm gonna ignore one character. Then I'm gonna read another d. Then I'm gonna ignore a character. Then I'm gonna read last one. So first one is for the month. Second one is for the day. For the year, I know in different places of the world they use it different, but this is how we use it here. We use month first, then day, then year. So read ignore, read, ignore, read. Yep. Then I'm gonna do the same, but I'm gonna print first. I'm gonna print month equal day equal, and then year equal month, year means day, year. Then I'm gonna do the same and enter different character. So first time I'm gonna enter, today's date is 7/8/2021. So it's 7/8/2021. If I do the same but 7/8/2021, it will also display it the same way. So it always skip one character no matter what that character is. So also you need to learn about this, skipping characters. And this is basically it, what you are responsible of for this chapter. So chapter 9, you're responsible for these topics, everything in here. So I'm gonna copy as is. I'm gonna say new text document like this, save chapter 09 or chapter 9.cpp. Oh, I didn't convert it. Anyway, I can go here, copy, or open, copy, paste. This is chapter 9, right? This is it. Then I'm gonna forward it to you. And we still have one more session since we are on it with the syllabus. One more session and then we review for the final and then we do the final. So we are here. We still have one session next Thursday, next Tuesday. Then on Thursday we review and then we have our final. Our final, I'm gonna send an inbox for the settings of our final. We need to prepare a camera. You need to open your camera and be in front of me doing your final. All of us in front of the cameras. I'm gonna send the settings later. And now I need to compose to you all chapter 9, because this chapter is pretty much memorizing, so I'm sending you this. Okay, good luck. Let me know if you have any questions.